Hi there everybody, I'm just going to do a little bit of a quick lesson on proofs. Okay, this is not the all-encompassing answer to every single proof question you're going to get, but it might give you a flavour in terms of how to approach them, what to think about, and all those kind of aspects that sometimes kind of throw a bit of a curveball into questions that you're after. Okay, so when I'm talking about proof, it's about not using numbers in most cases. I think a lot of students will tend to just put some numbers in and think that's a definitive proof. Unfortunately, it's not. It tends to be actually throwing some algebra into it and using that algebra as a proof. Okay, so we sometimes need to use algebra to prove statements. All right, so that's what that kind of idea is all about. So I'm going to give you some kind of techniques which you might want to know about if you're told certain things. Okay, so if you're told something is a consecutive integers, then obviously we need to think about what the first integer is. Well, now we're not going to put a specific number in there, so we're not going to say 4, 5, 6 or anything like that. They would be consecutive integers because we don't know if it's 4, 5, 6 specifically. So we need to use an inanimate number or letter to represent it. All right, so not a number, sorry, a letter to represent it. And you will find in most examinations, in most mark schemes, it tends to be the letter n to represent any number. Okay, so if we're thinking about our first one as being n, and then the one after it must be n plus 1, and then the one after it must be n plus 2, and so on and so on and so on. All right, so what you'll see there is 3 consecutive integers is n plus 1, n plus 2. All right, and that is what you would use if you're trying to do a proof regarding basically consecutive numbers. So if you have to prove that the sum of 2 consecutive numbers is something, then you'd have to use n and n plus 1. All right, that's what we would need to use. All right. So if you're asked to prove consecutive even integers, all right, well, what defines an even number? Well, it's a multiple of 2, okay? So if you think about a multiple of 2, then any multiple of 2, again, would be 2 times n, effectively. So 2 times 1, 2 times 2, 2 times 3, 2 times 4, but 2 times something, all right? So if you're looking at consecutive integers, then your first one needs to be 2 times something, all right? So if I said my first even number is 6, that would be 2 times 3. Okay, if I said my first number is 10, it'd be 2 times 5, 2 times something, all right? But because we're talking about, therefore, the next one, well, if I said my first one is 6, and the next one is 8, and the next one is 10, and so on, then what I'm doing each time is I'm adding 2 each time. Okay, so you're going to do 2n for your first digit, again, whatever the value that is, and then in each subsequent number after that, you're going to add 2 each time. So 2n, 2n plus 2, 2n plus 4, and so on. I hope you get the idea of this. All right, so we've got to understand what that actually means from an algebraic perspective, because we don't know what the actual numbers are. We don't use in proofs actual numbers. We use a little bit of algebra. All right, so please make sure you're taking notes on these. So if you're thinking about an odd integer, well, there is no way of kind of saying an odd integer specifically, of saying it's like 2 times table, all right, because it's going to be 1, 3, 5, 7. So it's not quite the 2 times table because it doesn't fit the 2 times, but it does go up in 2s. So there's 2 ways you can do this. You can say, well, it's your 2 times table plus 1. And if you think about that, it's 2, 4, 6, 8, it would be 3, 5, 7, 9. Or it's your 2 times table minus 1, all right? So arguably, either way you're looking at it, so you could use either of those, and it's likely to be the plus 1 because we don't want to deal with negatives. All right, so it's your 2 times table plus 1, and so on and so on and so on. And again, we're not really kind of like sure what the context of the question would be, but if you're asked to say consecutive odd integers, then we would write those because again we don't know what to do with them just yet. Okay, so an example of a proof. If you've got 4n plus 1 squared minus 4n minus 1 squared, and you need to show that it's a multiple of 8, all right? So what we are looking to do with this one, and again, it looks horrible, it looks in depth, but actually, arguably, it is just a case of expand those brackets and go into it. But what you should find, if it is a multiple of 8, then I should be able to divide it by 8. That means I should be able to factorize it by a multiple of 8, all right? So that's essentially what we're going to try and do. I'm going to go through the whole process of expanding all that. And then what should I do? If it is a multiple of 8, then it must be 8 times something. So I must be able to factorize it. And that would go for anything. If you're trying to prove that something is a multiple of a certain number, then you're going to use the algebra skills that you've kind of learned in the past. And then you're going to get to something at the end. And then, of course, you should be able to factorize it and take a number out of it. Okay. So let's have a look at this one. So when we expand 4n plus 1 as a double bracket, we've got 16n squared plus 8n plus 1. When we expand 4n minus 1 as a double bracket, we've got 16n squared minus 8n plus 1. That's that lot there. And of course, we're going to do this one, take away this one. Right, well, the 16n squared take away 16n is going to disappear. The 8n, and again, be careful here, minus minus, was a plus, is going to become 16n. And then a plus 1 minus 1 is going to disappear. So I'm going to end up with just literally 16n. Okay, so 16n. And from there, well, I can factorise that and basically take the 8 outside and show that it is a multiple of 8. It's 8 times 2n. Now, I suppose you could argue is, have I proved that it's a multiple of 16? Well, it certainly looks that way, doesn't it? All right, and it's certainly a multiple of 2 or 4, but it asked me to basically say it's a factor of 8. So I have to show that by taking the 8 out of it and whatever is left in there. And it doesn't really matter what's inside this anymore, because I'm going to times it by 8. And any number times by 8, well, surely is going to be in the times table. So therefore, I've proved what I needed to prove. All right. So proofs. All right. I've given you some examples there to kind of think about. I've given you kind of a worked example in terms of looking at it. I said I can't say exactly what you're going to in the exam, but you need to understand that when you're dealing with a proof, we are dealing with algebra. All right. It is very, very unlikely that if you start putting numbers into it, and it's very tempting to put a number into this, and get a multiple of 8, which you will get, is that strong enough or good enough? And the answer, unfortunately, is no. Okay, so please do go to the website maths-school.uk.co.uk. There are obviously a bunch of questions for you to have a practice at, but of course, please revisit this video at any point. All right, thanks for listening.